As a front-end programming language, JavaScript inherits the style and paradigm of the C language. However, there is another side to it: functional programming. At first glance, it seems that the functional style below is more concise and elegant. So, behind it, what is functional programming like? Let us find out. This is program flowchart with a tree structure, which seems to fit the object-oriented programming paradigm. We can clearly find the main program corresponding to the main class and the subprogram corresponding to the child process class. But if this node needs to call the interface of that module, the data here needs to be shared with these functions. Then, and then, how about this? If we use a hierarchical module structure to organize the code, it is really daunting. Let us forget all this. Let's think about who are the first class citizens of JavaScript: function. And there are functions in mathematicals, but that is kind of mapping. That is, a fixed input x is always a fixed output y, and the function does nothing except output the result. How pure and simple this is. So in functional programming, this is called a pure function. Not only that, the output of J's function can be rewrite of the input, which is not pure enough. Therefore, pure functions have another limitation: immutable data. In other words, no matter how complicated a data is, once it is created, it cannot be changed. Let's change the previous function a little bit. That is, we must copy the input value before rewriting. In this way, when a piece of data is used as input by any other module functions, there is no need to worry about being rewritten. However, if a complex object has to be copied every time it is modified and then rewritten, the memory usage would be too wasteful. In Clojure, a functional language, there is such a structure inside. Only the rewritten part will be copied each time, and the others will be shared. For example, the original data, here is the bottom row. When the data whose value is n needs to be rewritten, the fragment containing the value of n will be copied and modified in the upper position. To get the data in such a tree structure, you need to access it from top to bottom. In JS, immutable.js, immo.js, and etc. also have similar mechanisms. Where pure functions are the basic unit of functional programming, just like a water pipe. Data flows in from one end and flows out from the other end, without staying there and without any side effects. Then, no matter how complex the module is, you only need to combine multiple functions like water pipes. However, the real world is complex and changeable. We need to call the interface to read and write files, change the font size of the display, and so on. We count these all side effects. For example, when this water pipe is carrying water, it can also generate electricity by water conservancy. Therefore, functional programming probably has two parts. One is composed of pure functions, a utopian world, and the other is a side effect of communicating with the complicated outside world. Going back to the first example, the above example is an imperative style, which requires the programmer to give instructions one sentence at a time. The following is a declarative style. Once the water pipe is constructed, that is, the pure function in the middle, there is no need to care about the running of the programming. Having said so many benefits of functional programming, the current mainstream programming method is still an imperative style, represented by the C language. In recent years, JavaScript has set off a trend of functional programming. In fact, it is not necessary to switch to functional programming. When building complex and larger projects, the functional style is worth a try. And if it is a small scale, especially hierarchical data structure, it is more suitable for object-oriented programming.